Let's start with a magic trick today. I have a special liquid that makes glass disappear. I'll put a piece of glass in this container and it disappears. Fascinating, isn't it? But more on this later. Back to today's topic. Have you ever noticed some stars twinkle but others don't? Why is that? Actually, the stars which do not twinkle are not stars, they are planets. So then, why do stars twinkle but planets don't? This happens because the atmosphere bends the light coming from stars. Let's dig in further to understand. When a ray of light enters from one medium to another, the ray is bent. This is called refraction. This is the reason why half-sunk pencil appears crooked in a glass of water. This refraction varies depending on multiple factors like temperatures and density of the medium. Why refraction happens is a very interesting topic in itself. But let's leave that for some other day. Now, when the light coming from a star enters the Earth's atmosphere, it passes through different layers of the atmosphere, and so it gets refracted multiple times. These refractions can randomly change as the air and the other floating particles in these layers move around. This can result in the light reaching to you in one moment and refracting to some other point the very next moment, or somewhere in between. And this appears to us as twinkling. So then, why does the same not happen with planets? The light coming from planets refracts as well, but because they are much closer to us, they appear bigger and the light covers a wider area. So even though every point in this area refracts on its own, they negate the effects of each other to a larger extent. This gives the illusion that they are mostly still, and that's why planets don't look like they twinkle. This brings the question, do astronauts who travel to the outer space, leaving the Earth's atmosphere, see stars twinkle? No, they don't. The light comes to them directly, without being refracted or filtered by the Earth's atmosphere. And this applies to cameras as well. That is the reason we set the telescope in the space. Refraction is also the reason you see sunrises 2 minutes before the sun actually appears at the horizon, and the same for the sunsets. Here's a good experiment with refraction. See how the light is bending in this medium? But if I move it up, it goes through straight. This is happening because the liquid is denser towards the bottom. What I did was fill this container with water and then added some sugar. Did not stir it, just add it. And then let it sit for 24 hours. What happened is sugar dissolved and created the thickest layer at the bottom. And the layers as we go up are less dense and just water beyond a point. That's why the lower layers with increasing density bends the light. Something similar happens during summers as well. During hotter days, the air closer to the Earth's surface gets hotter, while the air is cooler as you go higher. So when the light coming from the objects higher up enters these hotter layers of air, it starts getting refracted. So much so that it reverses the direction of travel and appears to have reflected from the surface of the Earth. And your mind makes you believe that there is water to rationalize the delusion of reflection, called mirage. As promised, back to the magic trick. The special liquid is nothing but regular oil. The glass and oil have the same refractive indexes and hence glass in the oil disappears, as it allows the light to pass through in the same manner as the oil does. Your eyes, glasses, rainbows, prisms, cameras, microscopes, binoculars. Our life is full of refractions. Good refractions. Thanks for watching.